Real estate investment practice problem using Excel. Adjustable rate mortgage or ARM, this time with a payment cap as opposed to a rate cap, part number 2. Get ready because we're raising the stakes with real estate. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we have 3 tabs on down below: example, practice, and blank. Let's take a look at them now, starting with the example tab, in essence being the answer key. We started off looking at the standard fixed rate loan to compare and contrast with the ARM or adjustable rate, looking at the amortization table here that we'll be using as a starting point when we create our amortization table on the adjustable rate. We have a little bit different scenario than prior practice problems with the adjustable rate. We have the $100,000 loan, 30 years, 360 months, 9% on the initial rate. We have the 7.5 increase. That's going to be the annual payment cap. That's the difference. Then we have the margin of the 2%. We looked at the index, remembering that the index represents something that we don't have control over, it, something that we would be estimating what would happen into the future. And based on that index, we then calculate what our rate will be using the margin at 2%. Then we thought about what the payment would be if there were no restrictions, because we have that payment restriction item in place. Then we focused in on the caps or the restrictions here, thinking about it intuitively to figure out what those restrictions would be. As we thought through that, we also had to calculate the ending balances, which we did with a calculation in our table. Now we're going to go back through this. We're going to be thinking about then the construction of the amortization table and what these caps will do, or what the impact will be on the amortization table, also checking our ending balances. Then we'll go back in a future presentation and think about these caps with regards to if or logic functions. So let's go to the practice tab. Remember, this tab has the information laid out with pre-formatted cells, which could make it a little bit easier to enter this data into the practice problem. We're working on the blank tab, where we did this whole thing from scratch. And so now we've got our information on the left-hand side. This is what we have constructed thus far. The index, the rate. We had the payments. If there was no restriction, we capped the payments, thinking about what those would be. Then we had the ending balances here. Let's construct now our amortization table. So I'm going to go to the left-hand side. We're going to pick up the amortization table over here as our starting point with the standard 30-year fixed rate, and then adjust it. So I'm going to put my cursor on column C with that skinny column. Drag on over to ICI, left click on it, or right click on it, and copy it. Bringing that on over to column U, and then right click and just paste that on down, pasting it down. There we have it. We got the skinny column U now, and then U skinny, that column U skinny. And then we're going to go on the right-hand side and enter our data. So we're going to have to adjust any kind of items over here that were going to be absolute references. So I'll double-click on this first one. This one has the B17. Let's delete that. And now we got to bring this up from our current data, which I'll pick from the first item, which is here on R3. Let's select F4, keyboard, $ before the R and 3, enter. Put our cursor back on that, double click on the fill handle, bringing that all the way down. Let's do that to the interest now. Interest, that B7, that's not right, because that's pulling from the prior data. And we want to be pulling that from here. Let's pick it up from 9, make it P3 instead. Hit the old absolute on the keyboard, which is F4 on the keyboard, $P, $3. $P, $3. We also need the loan balance up here, because that's not there. That's going to be necessary for stuff to work the way it's supposed to. And then I'll put my cursor back on this interest one, double click on the fill handle once again. And then this should calculate all the way down, and we should be able to double click or double check that it's 0 at the bottom, which gives us that indication that stuff has been done the way stuff's supposed to be done. There's the 0. So that gives us a bit of a double check. Now, the funny thing here is that won't always be 0, because we have these funny caps that are happening here without the rate change. So that's where this unusual stuff's going to happen. Let's make this banded. I'm going to make it banded by making different colors, different bands of color. Bandits. We're going to put a face mask on it because it's now a bandit. It's now a bandit. We're going to put a green face mask on it right there on 2. And then 3 is going to be non-banded. And then 4 is a bandit. That's where the band goes. It's a bandit. So we'll put a band on that one. The green face mask. So they can, and so there it is. It's not a COVID mask. It's a bank robbing mask because it's a bandit. And then we're going to put a band down here on 6. Let's do that one too. Okay. So we got our bands in place. So that looks good. So now we know what year's what. We know what is what now. Now at the end, we can kind of check our ending balances as we go. If we go down here, we've got the 99,317 matching out to the 99,317 here that we got to with a formula. That's good. And then in year 2, things changed. What didn't change was the rate. But with that rate, we would be paying $1,025.31, and we capped it at $864.97 because we said we couldn't go over 7.5% of the prior payment. So that means that even though we're calculating interest using this rate, we're actually going to cap the payment right here. So I'm going to go to my payment right there and say, what if we just capped that at the $864.97. So we're going to cap that there. I'll bring that all the way down, double clicking on it. But then the interest is going to still go up to 12%, even though the payment's not matching it. So let's double click on the interest, and that P3 is now looking to be P4, F4 keyboard, enter. And now you can see what happens. Let's double click on that. I'll put my cursor back on it, double click on it. This last one, there was a problem because I didn't make it absolute. I need to make that absolute. I'm going to put F4 on the keyboard, enter, and then double click it down. So there we have it. I think that works now. Now we got the payment from here, and we changed the interest rate all the way down. We get this negative thing. That's unusual. That looks funny. Isn't something wrong there? Well, notice what happened is the payment is not based on the interest. So that means that this interest calculation is calculated on the prior balance on that 12%, which we're still picking up. But we're paying an amount because we capped it that's not even enough to cover the interest. So that could lead to this kind of negative amortization type of thing, the loan balance actually going up. So notice what the impact of this kind of cap would be. It can be kind of nice that you don't if this jump happened in the interest rate, then you don't have this this kind of possibly as big an effect on the payment, but you have the balance go up basically here, and that means that you can actually have an increase in the in the loan balance. Now the other funny thing is that if I copy this all the way down, I can't really double check it all the way down because it's not going to come out to be even basically at the end of the table in this format, because we didn't use the proper payment matching up to the interest amount. So we don't get this nice zero balance as we did when we did basically the rate changes because we increased the balance. In other words, again, we have the percent increasing, but we weren't able to adjust the payment to match the percent increase. So let's do that again. Like if I use that payment, I go to the bottom of year 2. Let's look where we're at. We're at the 109.43. So that calculates properly here. So that looks right. Let's go to year 3. Let's make it green so I know where I'm at this time. It's green. So then it went up to 15%, which would mean that we would have the 1,281.51. But then again, we only capped it at 929.84. So it should be that amount because we're going to let the interest rate go up and amortize upwards, but we're not going to be paying that much, which means the balance in the loan could go up. So that's where the funny business happens. Funny business. The business is funny here. So we're going to say that's happening in year 3. So in year 3, we're going to say the rate or the payment amount stopped at that 929.84 this time. There it is. We're going to select F4 on the keyboard, $ before the R and the 5, put our cursor back on it, double click on Phil's handle, the Fill handle button, and then double click on the next one. The interest rate has now changed to be that 15%, F4 keyboard, $P, $5, enter, put our cursor back on it, double click on down. There it is. We've made the problem worse we've worsened the problem, so we can still afford the payments here, but the interest rate has now gone up, and now we're negative amortizing. And again, if we go all the way down to the bottom, it's not like it's going to go to zero here, because basically we're now increasing the balance instead of decreasing it due to that fact. So then let's do it again. I'm going to say, okay, well, what happened next time if we say ungreen that number 4? Now we're on number 4. Let's make that green. And the situation has worsened again. So now it's at, and so I can double check this 105.212 too. That's at the end of year 3. So 105.212 does look like it has that. So let's do the next one. This one's going up to 1506 to match the 17% increase in the rate, which we're still going to use to calculate, but that's way over, because we're going to stop it at the 999.58 in year 4. So year 4, we're going to say, all right, we're going to increase the payment, but only to this 999.58. So that's good. We can afford that. I'm going to say F4 on the keyboard, but the loan balance is going up. The loan balance is going up. That's about 1,000. So we're going to say double click on that one, and then double click on this one. We'll get rid of the rate here, and now the rate went up again to 17. Now we're at 17. It's just absurd. F4 on the keyboard, $ before the P and the 6, and enter. Double clicking on that one, bringing it on down. Again, the problem has once again worsened. By the end of year 4, we're at that 11,584. So that looks like the ending balance is calculating properly there. Let's do it one more time. Uno, vez, mas, por favor. This is the last one. So let's make that one green. We're on the final one here. So then now we went down to 12. Some sanity has been recapped, has come back to the world. So now we're at the 1168.23, but still that's over the 1,074.55. So if we go down to year 5, and say we're going to do that right here, the payment is now going to be capped payment of 1,074, and F4 on the keyboard, $ before the R and the 7, double clicking that on down on Phil's handle, and then we'll go into the rate and fix the rate from P6, which was an absurdly high 17%, down to 12, which is still kind of high on our days, but depends on your environment at the time. So we're going to say F4 on the keyboard, $ before the P and 7, enter, put our cursor back on it, double click that one on down, and we still got the negative amortizing, which isn't good, but at least it's smaller negative amortizing here. And if we go to the end of year 5, we're at the 112.108. So you can see what's happening here. This could be beneficial in that it doesn't get things out of control in terms of payments, so you could think that you can keep on affording the payments, but then, of course, we could end up in a situation like this where you got this negative amortizing and the loan balance is actually going up, which might not be a huge problem because the home value, could be going up as well, given the circumstances. If there's a high period of inflation, you would think that might be the case, and so on. But you can see how that plays out, and it's a little bit different, of course, than the rate change one, where you see the rate changing, which might indicate or might result in a bigger difference or fluctuation in the payments that could be involved. But that one we can kind of check out to the amortization table kind of pretty neatly and still basically verify it and have the whole amortization table kind of matching out on those two. So there's pros and cons of those kind of different scenarios. Next time, we're going to go back in here and we'll take a look at these cap limits and try to do these with a logic function instead of just kind of intuitively doing it, so that we can do different scenarios. You can see this would be more of a worst case kind of scenario, or bad case kind of scenario that is going up, and you can run different scenarios and see what the impact might be. So it'd be nice to be able to do that if you can change your data on the left and have this populate automatically, which you can do more easily if you enter the logic functions So we'll do that next time.